Hello guys, welcome to another video of Kubernetes. In today's video, we are going to discuss about Kubernetes services. We'll see what are services in Kubernetes, why we use services, and how we can create the services, and what are the different types of services in Kubernetes. Okay, we'll discuss everything. Let's begin the video. If I talk about the services in brief, this is nothing but a medium to communicate with your pods. That can be you communicating with your pods or users or even pods communicating with each other. We use services to do that. Okay. So there are multiple types of services which we use in Kubernetes. You can see here in the screen like ClusterIP, NodePort, Load Balancer service, Ingress service, and ExternalName. We use all these services to communicate with our pods. Okay. So we use ClusterIP. This is used for communication between applications inside your Kubernetes cluster. Okay. So suppose you have one front-end pod and you have one back-end port, and you will have to make communication between them. You will have to use ClusterIP service to uh, make back-end application available to front-end application so that they will be able to communicate with each other, and front-end application will be able to communicate with your backend. Okay, like that we have NodePort. This is used to access applications outside of your Kubernetes cluster using worker node ports. Okay, if you want to access your application in a browser, then we use this node port. This also works as a load balancer, you can say. It if you assign a node port service to multiple pods, it will route your traffic to those pods. Okay, so generally we use NodePort service to access our application, which we have deployed in Kubernetes from a web browser or with some anything like you can do curl wget or whatever you want. With that you can access the application with NodePort. Okay, the next one is load balancer service. Generally we use this service to communicate or to access our applications in the browser or outside of the Kubernetes cluster. Same as NodePut, but this is load balancer service is mostly being used for the cloud providers to integrate with their internal load balancer service. Okay, so if I take an example of Microsoft Azure, and if you are creating load balancer service, Azure will internally call or internally create a load balancer, will assign the front end IP address, will add the backend pools and all in the backend. Okay. In case of AWS, it will create an AWS Elastic Load Balancer. Okay, the next type of Kubernetes service is Ingress. This is an advanced load balancer which provides context path based routing, or you can say host name based routing. This also provide SSL and SSL redirect, other things, and many other things like this. So this is being used. This generally we use to do the advanced type of load balancing. Okay, like you can say you can take an example of application gateway in Azure. Okay, there we can use the SSL offloading or context path based routing or something like that. So even in Ingress, we can generally do that. Okay, we even provide the host name so that if this some particular X host name matches, it will route our traffic to the X application. If host name is Y, then it will route our traffic to the Y application hosted in same Kubernetes cluster. So something like this, if we have to achieve it, we can use ingress service for the same. Okay, and the last one is external name. If you have to access some services from the cloud in your Kubernetes cluster, like if you want to access AWS relational database endpoint, then you can use this external name service. Okay, if I give you an example in Azure, if you have to use some service like PostgreSQL database inside your Kubernetes cluster, you will have to create an external name service to do that. Okay, let's move ahead. You can see the diagram here. This is my Kubernetes cluster. Okay, and inside that we have all the resources created, like deployment. We have a deployment for front end app, and we have one deployment for back end app. Inside that we have replica set, and inside replica set we have three pods in front end and another three in back end. Okay, so to communicate our back end pods with front end pods, we have created a cluster IP service. Generally, if you want to communicate between pods, you will have to create the cluster IP service. Okay, and if you want to access your front end application, or if you want to provide some URL or some IP address to users, you will have to create NodePort or load balancer or ingress service, so that users will be able to access your application with that IP or maybe the DNS. Okay, you can assign the DNS to your IP addresses, and your users will be able to access the application with the load balancer IP, ingress service, or nodeport IP. And if you want your backend to communicate with your relational databases, that can be in any cloud, Azure, AWS, or GCP, you will have to create one external name service here. Okay, so this is how we create the services in Kubernetes. To communicate with an external service, you will have to create external name service. To communicate with your pods inside your cluster, you will have to create the cluster IP, and to let the users access your application, you create the node port service or load balancer service or ingress service. Okay, like we can see here, if your users uh, are trying this application something like this, if you have created a load balancer service, and your this is your load balancer IP or your application URL. If they hit this, it will come to your load balancer service. Load balancer service will send the traffic to this pod, which is the front end pod. Front end pod, if the if data is required, it will reach to the backend pod with the help of cluster IP service, and this way it will be able to communicate with the backend port and send the data to the users. Okay, this is the example of load balancer service in Kubernetes. We can expose an application running on a set of pods using different type of services available in Kubernetes, like cluster IP internal to Kubernetes cluster, NodePort service to internet, load balancer service to internet, ingress service to internet. Okay, you can expose these three services to internet, but not to the cluster IP service. It will be internal to your Kubernetes cluster only. Okay, to access our application outside of Azure AKS cluster, we can use Kubernetes load balancer service, which will be eventually mapped to Azure load balancer, which I have already talked about. Like if you are creating an Azure load balancer service, it will internally create an Azure load balancer resource in Azure, and it will automatically map the backend details, it will automatically create the rules, and it will automatically assign the IP address as well. Okay, when we deploy create load balancer service, the following will happen in the Azure load balancer. Azure standard load balancer. A new public IP gets created and associates that to front-end IP configuration. A new load balancing rule will be created which associates front-end IP and the backend pool, which we just discussed. If you see the diagram, we have an cloud. Inside that we have a Kubernetes cluster. We have the worker node, and inside that worker node we have a pod. And you can see the service is there with the current port and target port. Target port is nothing but the container port, you can say, and the port is service port. Okay, container port in a pod, cluster IP service port, and if you have created the load balancer service, it will automatically assign the backend pools inside your load balancer, and you will be able to access your application with the public IP of your load balancer. Okay, if we see this diagram, we have three pods here, and there are some users here. Just how we already discussed, users can communicate with this pod with the ingress service or NodePort service or load balancer service. Okay, so here we can have three services. But in case of these two services, this is another pod and this is also another pod. So this pod should be communicating with this pod with cluster IP service, and even this pod and this pod will be communicating with each other with cluster IP service. After this, we have a database, and these pods, the backend pods you can see, or any other pod, can communicate with the database with the external service. So here we are creating external service where, and here at the two places we are creating cluster IP service, and at the top where users are accessing our application, we can create either load balancer service, node port service, or the ingress service. Generally, if you are using AKS, node port is not currently supported. That is in preview. Okay, so you can use load balancer service in AKS as of now. Let's move ahead. You can see the more examples here how we can create the service. Like this is our pod, and this is my pod IP address, pod subnet range, and 10.2.244.0.2. This is the IP address of our pod. Okay, so if you have just tried to access this IP address, you cannot directly access this pod. Okay, you will have to access this pod via service, and suppose this is a worker node and 192.168.1.2 is the IP address of your worker node. Okay, and you have created a service, so you can access this pod with curl http IP address of your worker node and the node port which has been assigned. Okay, like this you can access your node port pods. We already have discussed this. Generally, these three are the important ones in the services type: node port, cluster IP, and load balancer. Okay. In case of node port, you can see this is the pod and this is the pod IP address, and we have created a node port service here. Okay. Here you will have to provide the service port, target port, And there is also called a node port, that is this port assigned to the worker node. Okay, if you see the detail in here, the node port range should be between 30,000 and 32,767. If you are providing the value of node port, then it will check and assign that port to your service. If you are not providing, then it will take some default port from this range. Okay, and this is the service port, that is 80, and this is our target port, which is nothing but container port, that is also 80. So if you access your application, then you will have to access with your uh, worker node IP along with this 30,008 port number. Okay, and service will communicate with your container with the port 80. That's why we configure this port. Okay, you can see how we write the YAML definition of creating the service. We provide the API version, kind, metadata, and spec. In API version, we provide v1, kind is service, metadata, you can provide any name, and in spec you can see type is the node port. Ports we have provided target port is 80, and this port is 80, and node port is 30,008. Okay, so with this configuration, this will create a node port service, something like this. Okay, if you just type kubectl create hyphen f service definition.yaml, so this will create a my app hyphen service which we have given here, and you can type kubectl get services command to list the services which we have created. So you can see the second one which we just have created. If you do the curl and URL of your worker node along with the port node port, this will this will show you the response. Okay, even in this you can see how we can use this node port as a load balancer service. Not you can say the load balancer, but you can also use this node port to balance the load. You can create a service here and you can have multiple nodes, and we can provide the selectors and labels in our service so that all the pods with the same label will be assigned to this service. Okay, and if you have this pod and this is the worker node, these three are the worker node, you have one service node port service, and you have three pods. You'll be able to access the application with something like this: 192.168.1.2 and the port number, something like this. Okay, and in case of cluster IP, we have seen if we have the front end app here, and this is back end, and this is our database. This is how front end will communicate with the back end with the cluster IP service. Back end will communicate with the Redis database with the cluster IP service. If you are creating the YAML of the cluster IP service, you don't need to provide the type. Even if you don't provide the type here, it will automatically take the cluster IP. Okay, so this is the YAML definition of creating the cluster IP service. Everything is same, just the type is different. And we are not providing node port because that is not needed here. We just need the service port along with the target port. Okay, if you type kubectl create hyphen f and the service definition file, it will create our uh, this uh, service. Okay, that is nothing but back end service. And if you type kubectl get services, it will list all the services here, and you can see the backend cluster IP service has been created. You will have to, if you want to communicate with each other, I mean with all the nodes, you will have to add the changes inside your application. You will have to provide the host and all in all the applications. Okay, like how we are providing the host is equal to redis in here. Okay, something like this. That's it from this video. In today's video, we discussed everything about services, how we can create the service, what are the types of services, why we need to use the service, and generally why we use this. Okay. If you have any doubts or suggestions, please let me know in the comments. If you liked the video, please like and subscribe my channel. Thanks for watching.